Hi everybody. I have had some questions on chapter 10 lesson problems. So before I send out any kind of assessment or test, I'm going to run through some questions people have been asking. I just feel like this is the best route to go, and instead of responding to 3 or 4 people, some of the quiet people out there might prefer seeing and hearing some of this as well. So I have highlighted the lessons the problems come from in yellow. The number of the problems, like you can see on this screen right now, number 48 from lesson 10.1 and number 63 from lesson 10.1. I did not include the page numbers, sorry about that, but I'm pretty confident you can all find them. So lesson 10.1 was really like combining like terms. You're adding and subtracting polynomials. So if I start with number 48, since this is a subtraction problem, I am assuming that the person that asked me to do this problem just probably got some of the negative or positive signs goofed up a little bit. It says for the directions on number 48, you can use either the horizontal or vertical model. So I'm just going to do horizontal because it's my favorite, and it literally is just combining like terms. So when I take a look at this number 48, and I have a negative 2t to the fourth, and I am subtracting a negative, which would mean I would be adding 2t to the fourth. I'm just going to write that on the top, okay? Negative 2t to the fourth. Instead of subtracting a negative, I'm going to write it as adding 2t to the fourth. This term right here, adding this term right here, is really going to cancel those two terms out, because if you have a negative and a positive of the exact same thing, it will equal 0. So that's just 0. Then you have the 6t squared. You are subtracting 5t squared. So if I have 6 of these and I'm subtracting 5 of them, I have 1 of them left. So t squared, you can write a 1 in front if you'd like. And then you have a 5, and you are subtracting 1. So 5 minus 1 is a positive 4. And that should be your result. All right, so basically just combining like terms. I got the 4 from doing 5 minus 1. That would be my answer. So if you have questions on these, feel free to email me. A couple of you have sent me videos of yourself asking questions, sort of like how I'm doing this with teaching, saying things like, well, I don't understand, what you did here, etc., and showing me their work. That works great. So number 63 asks to write an expression for the land that is around the house, and I have drawn the diagram here. So these are just this area model. This factoring business, like what we're doing in chapter 10, is so important for geometry, because you're going to see things like number 63 and the examples I'm going to show in 10.2 in geometry next year. Basically what I'm doing right now, this is geometry because we're talking about areas of rectangles. So if I only want the green land area, I can take the area of the whole big rectangle and just subtract out the area of the house, and I'll be left with the area of the land. Okay, so length times width, area of the, I'm going to highlight this in yellow. I'm now finding the area of that entire big rectangle, the one I have in yellow. Area is length times width. So I'm going to take 3x and multiply it by x plus 20. 3x times x plus 20. That represents the area of this huge triangle. If I subtract out the house, which the area of the house, again, length times width, is going to be x, or width times length, I guess I wrote it as, doesn't matter, depends on how you see it, 1.5x. Okay, those are the dimensions of the house. Length times width, the area of house. I'll write it that way. Area of house and land combined, or a large rectangle like the yellow. Okay, But in order to subtract these, you are going to need to use the distributive property and multiply everything out. So 3x times x is 3x squared. 3x times 20 is 60x. I'm going to put this in parentheses. Subtract and then 1.5x squared. Okay, so if you're combining like terms, basically, those are the same. 3x squared minus 1.5x squared gives me 1.5x squared. And then you don't have anything to subtract from the 60x, so plus 60x. That would be an expression. There's no equal sign in that. 1.5x squared plus 60x is an expression for the area of the land around the house. I am not looking at the answers in the back of the book, so if I am writing something that is not an answer that you're seeing in the back of the book, it's still a correct answer. Maybe I've written it in a different form, and feel free to ask me about that. Email me, send me a video, post something in Google Classroom, whatever you want. Sorry, I'll turn the volume down on my phone. It's kind of going off. All right. So that's 10.1 questions. 10.2, still geometry. So 53 on 10.2, write an expression for the area and write it as a quadratic polynomial. Maybe the vocabulary here is bothering someone, that's possible. But to find the area of a triangle, which that's what that shape is, a triangle, the area of a triangle is 1/2 times the base times the height. You know, if you must, you could change that to a 0.5. I'm not going to, so I'm just going to write 1/2 times the base. Base is 6x minus 5 times the height, which is x plus 4. All right, so that would be the area of my triangle, but it is not written as a polynomial. This is written in factored form, okay? So in order to have it as a polynomial, you are looking at terms like separated by plus or minus signs. Really, the definition with terms is that it's things that are being added. But again, a subtraction sign can be changed to an addition sign if you add the opposite. So, all right, so I'm going to multiply this through. 1/2 times 6x is 3x. 1/2 times 5. You can write it as 5/2. You can write it as 2.5. You could write it as 2.5, I guess. I'll write it as 2.5. Okay, so it looks like that. And then so multiplying this out, 3x times x, 3x squared. I just did this. 3x times 4, negative 2.5 times x minus 2.5x, and then negative 2.5 times 4, 8, 9, 10. Yep. Okay, 3x squared, combining these, 12 minus 2.5, 12 minus 2 is 10, minus half, 9.5, minus 10. All right, there you go. Why is it quadratic? So this says write it as a quadratic polynomial. Why is it quadratic? Because the highest exponent is x squared. You have an x squared, that's making it quadratic. It's a polynomial because poly meaning many, it has many terms. It's actually a trinomial specifically, but that's the area. If you wanted to label it as units squared, that'd be fantastic. Okay. 54, very similar. So area of a football field, this time it says as a quadratic trinomial. This was a quadratic trinomial, so basically the same directions as 53. This one may be a little easier because it's not a triangle, so we didn't have to do 1/2 base times height. It's a rectangle, so we just need to do length times width. which is very similar to base times height. Okay, so 5/4 x minus 15 is the length. 1/2 x plus 10 is the width. And we're practicing what we were learning in 10.2 by multiplying this out. So 5/4 times 1/2, if you have to, 5/4 times 1/2 equals 5/8. Okay, you can do that on the side if you need to. So 5/8 x squared. Remember the fraction practice that we did? It's important if you're still struggling with those fractions, you need to find some fraction practice online. They're not going to go away. 5/4 times 10, 5/4 times 10 over 1. You could write it as 50 over 4. You could divide that by 2 and make it 25 over 2. That's what I'm going to do. So plus 25 over 2x minus, and then I'm going to do the 15 times 1/2, which is going to be 15 halves. See, now when I do these fractions, they have a common denominator. It's not going to be that difficult. And negative 15 times 10. All right, let's combine these terms. Sorry about my shadow there. So I'm going to rewrite the 5/8 x squared. Combine these. 25 minus 15 is 10. And so 10 over 2 is just going to be 5. And it's positive. Plus 5x minus 150. And that should be your expression. It is quadratic because it has x squared. 2 is your highest exponent. It is a trinomial because it has 3 terms. 1, 2, 3. Okay, so hopefully that helped. I would love feedback on, yes, Mrs. Stofflet, this helped. Post it on Google Classroom for the world to see, or email me separate so no one sees. Doesn't matter to me. Okay, so those were those two. I didn't have any questions on 10.3, which was a little surprising to me. So 10.4, number 49 is probably the best question, because this was using graphing and find the x-intercept and vertex to sketch the graph. But on this problem, when you look at these two factors, the negative x minus 2 and the x plus 2, you get the same x value when you solve for 0 or try to find the x-intercept. So when you do 0 equals negative x minus 2 times x plus 2, and you do negative x minus 2 equals 0, add the 2, negative x equals 2, multiply by a negative 1 or divide by a negative 1, x equals negative 2, right, for your solution. When you do this one, the x plus 2 equals 0, and you subtract the 2, you also get x equals negative 2. These are not different results, so you're not going to have two x-intercepts. They're going to be the same. If you only have one x-intercept, it's your vertex. Okay, so what are we going to do about that? Oh, so I'm actually sketching a graph, and I'm going to say 1, 2, it should be further, but anyway. Negative 2, that's your vertex. If you have to sketch a graph, that means you need to make a table, because you need more than one point to somehow come up with a parabola. So since in this section anyway, when you're sketching a graph, you only have 3 points, let's do the negative 2 and put it in the middle, and just go negative 4 and 0 and see what happens when we put those into the problem, okay, to get the other values. So when you put a 0 into this purple problem, can you see the different colors? And I write y equals, remember that negative sign is out front. 0 isn't negative. So 0 minus 2 and 0 plus 2. replacing, I am replacing these x values with 0 right now and solving for y, you'd get -2 times +2, which is a -4. So your y value is a -4 when you put a 0 in, -4. This is a parabola, so this should match. If you put a -4 into the problem, and you can try it, you should also get a -4. So if you graph this, you're going to have 0, -4, sorry, and you should have -4, -4. Okay, and there you go for your beautiful graph. Okay, 27, sorry, this was a little backwards. Could have done 27 before 49, but 27, it says to solve, but in order to solve it, you need to factor it. Well, you could use the quadratic formula. You can solve by graphing. We are still working with quadratic expressions. It's really doing the same thing, but we're going to factor. So seeing that I do not have anything out in front of that x squared, or my leading coefficient is 1, I can just find two numbers that multiply together to equal 10, and those same two numbers should add together to make 7. So my numbers are 5 and 2. That just means x plus 5 and x plus 2 equal to 0. Solving means what would the x value have to be in this factor in order to make it 0? So I'm just going to say -5 plus 5 would make that 0. That's one of my solutions then. And a -2 plus 2 would make that equal to 0. So my solutions are -5 and -2. They're my x-intercepts. They're my solutions. All right, there's 10-4. I'm just rolling along here. All right, 10-5 did not have questions, so 10-6. Had quite a few, actually. So number 27, factor if it's factorable were the directions. Okay, so this is a lot more challenging, I think. I want to say it's a lot. So when you look at 27, there is a leading coefficient that is not 1. As a matter of fact, it's a 14, so yuck, that's a big number. But you have to take this coefficient and multiply it by the last term or last, I'm going to still call it a coefficient because it is one. So multiply 14 times 4. And you should get 56. Meaning you need to find two numbers that multiply together to make 56. Those same two numbers should add together to make still that middle, so a -15. I know that 7 times 8 makes 56, and I know 7 plus 8 makes 15. How do I make this answer positive when I'm multiplying, but this answer negative when I'm adding? Just means your two numbers both need to be negative. So -7 and -8. You know, some of you, I think, are probably just having difficulty finding the numbers. You need to persevere because you just need to ask yourself, I mean, maybe you have to list all of the factors of 56. So like 1 times 56, too far apart to add together to make 15. 2 goes into 56. How many times does 2 go into 56? 28. Okay, 4. Does the number 4 go into 56? How many times? 4 times what makes 56? 14. Still not working, right? So keep asking yourself, does 5 go into 56? No, it would have to end in 5. Does 6 go into 56? No, because 6 times 8 is 48. 6 times 9 is 54. 6 doesn't go into it. Does 7 go into it? Oh, that's right, 7 times 8. Okay, so list all your factors. It's maybe a lot of work to do, but it's going to help you find your two numbers. Once you find your two numbers, they go in the middle. You rewrite the first term. So 14y squared. Your -7 and your -8 go in the middle to create this -15y. So I'm going to write -7, you have to put the y on it, -8, also with a y on it. These two middle terms, the numbers that you found, make up that middle when you add them together. That's why they need a y on them. And you rewrite the +4. Okay, so after you find your two numbers, let me go back. Multiply the front and the back. Your two numbers have to multiply together to get the result of that. They have to add together to give you the middle. You now have a polynomial with 4 terms. That's always going to be what happens when you have a number out in the front that is not 1. Once you have the 4 terms, you will separate the front 2 terms from the back 2 terms with parentheses. You then proceed to factor out the greatest common factor from each separate pair of parentheses. So what can I divide out of 14y squared and -7y? I can take out a 7y. 7y times 2y will give me 7 times 2, 14, y times y squared, minus, if I divide 7y by 7y, it should be a 1. I promised you earlier when I taught it that when I factor this second binomial, this second part right here, and I divide something out of it, my result should be this very same thing. I like to just rewrite it and then think, well, what am I going to divide a -8y by to have it equal 2y? And I'm saying you're going to take out a -4 or divide by a -4. These two parts come together, 7y minus 4. And the 2y minus 1 just gets written once. So there you have it. This is factored form of this very same trinomial. So expanded form, factored form. That is your result on 27. Back of the book wise, these can be flipped around. They're factors. So it's okay to write 2y minus 1 in the front in parentheses and followed by the 7y minus 4. That's okay. All right, 29, very same process. Again, if it's just trying to find the numbers, you got to persevere. You got to keep going. Okay, so I'm going to multiply 6 times -70. And I'm going to get a -420. Oops, there you go. Can you see that? So your two numbers have to multiply together to give you a -420. But when you add those two numbers, they need to make, and there's no number there. That number is a 1. So they need to add together to equal 1. Like, holy cow, I guess, if you're writing factors of 420, but just know this, like, they're only 1 apart when you add them. I'm going to guess since I'm multiplying and getting a negative, one of the numbers has to be negative, one has to be positive, and when I add them, I'm going to get 1. So those two numbers, you know, this is making it up, but they have to be like 17 and 18, or numbers that are right next to each other because their difference is just 1. In my brain, I know if I just round this, I look at this, 20 times 20 is 400. So I'm thinking maybe I have to be somewhere close to that. And then thinking of what numbers go into this. I mean, you can divide it by 5. You can divide it by 10. Can you divide it by 20? So you just have to use your number sense of getting the factors for this. The numbers are, in this case, 20 times 21 make 420. but when I add them, I need to get a 1. So I'm going to make a positive 1. So I'm going to make the 21 my positive number, and I'm going to make my 20 the negative number, so that when I multiply them, I get a negative 420, and when I add those two numbers, I get a 1. All right, entire process one more time. I am going to rewrite this 6t squared. The first term simply gets rewritten, 6t squared. Those two numbers that I just found, the 21 and the negative 20, will go in the middle to create that 1t. So they have to have t's on them. So plus 21t minus 20t. And I rewrite the negative 70. Again, when there is a leading coefficient that is something other than 1, you will end up with 4 terms when you're factoring at this stage. You separate the front 2 from the back 2. You factor them like they're 2 separate problems. What can you divide 6t squared and 21t by? Think about the numbers, 6 and 21. I can divide them both by 3. I should get a 2t squared. Oopsie, sorry about that. I can take out a t. I'm going to cross that off. They both have a t, so 3t. I'm going to write a 2t here then. So 3t times 2t makes 6t squared. Here's what I'm saying. Sorry about that. Divide. And this would equal 7. So plus 7. And I'm going to rewrite that. 2t plus 7. So what am I dividing a negative 20 and a negative 70 by in order to get this as my answer? Negative 20 divided by what gives me positive 2? I'm going to say a negative 10. And then you can check, like if I multiply this, negative 10 times 2t, yes, it gives me a negative 20t. Negative 10 times 7, yes, it gives me a negative 70. These two go together, 3t minus 10, and I write the 2t plus 7. There you go. All right, so that was 27 and 29. That was asked of me at 10-6. It's a long process. I'm telling you, that is a long process. 10-6 keeps a rolling here. So number 43 on 10-6. I think the directions on this section, when we get to the higher problems, say to solve. That means you're finding the x-intercepts. It also means you're moving everything so that you have 0 where the y is. So I'm going to add 2x and subtract the 8. Add 2x minus 8 on both sides. Leaving me with 10x squared plus 3x minus 18 equals 0. All right, so I have to factor this, and I have to multiply the 10 times the negative 18, not forgetting about the negative sign. So 10 times negative 18 is a negative 180. I have to find two numbers that multiply together to equal a negative 180. Those same two numbers have to add together to be 3. So one more time, those numbers are not going to be very far apart from one another. You might have to start listing factors of 180, as in 18 times 10. That's 8 apart. 18 and 10, I'll just write this down. Like, am I questioning that? Those are 8 apart, so I have to get closer together than that. So, you know, like if you were to guess, oh, 5 goes in there. Yeah, but that's just going to spread your numbers farther apart. The numbers that you're thinking about going into here are numbers that are going to be between 10 and 18. So keep trying. I'm going to tell you, I'm going to give them to you, but you know, you have a calculator. Grab your calculator and just go 180, what goes in there? Does 11 go in there? Does 12 go in there? Does 13 go in there? Does 14 go into it? Does 15 go into it? Does 16 go into it? Until you find two numbers that are 3 apart. So the numbers are 15 and 12. I'm going to make them 15 and negative 12 so that when I add them, I get a positive 3. Rewrite the 10x squared. The 15 and the negative 12 become 15x and negative 12x. And you rewrite the negative 18. You can rewatch this over and over if I go a little too fast. Separate the front from the back. Front 2 terms, back 2 terms. Factor them separately. So I can divide 15 and 10 by 5. They both have an x variable. If I divide 10 by 5, I get 2. If I divide x squared by x, I get x. If I divide 15 by 5, I get 3. If I divide x by x, I get 1. So I don't need that there. I promise you, when I factor this, I will be left with 2x plus 3. So hey, well, 18 divided by what makes 3? And that should be a 6, and it's looking like I have negatives up there, so I'm going to write negative 6. These two come together. 5x minus 6, and the 2x plus 3 is the other factor. And we are solving, so this is equal to 0 because you are still finding x-intercepts. So what if 5x minus 6 equals 0? Solve that. What if 2x plus 3 were the factor that actually equals 0? So add 6 to both sides, divide by 5. X could be 6/5. If you want to call that 1 1/5, that's fine. If you want to call it 1.2, that's okay. I'm going to subtract 3 and divide by 2. X equals a negative 3/2, or a negative 1.5, or a negative 1.5. Keep working with those fractions, people. They're fun. You too might enjoy them someday. Okay, another question that was asked of me was 47. 47's kind of a doozy, but persevere. Let's see if we can figure this out. I'm going to do it very much like 43. So I'm going to subtract the 67x and subtract the 30 from both sides, so I get equals to 0 since I am solving. So negative 67x and negative 30. You'll be able to see it when I write my result. All right, so the 18x squared didn't do anything to that. Negative 30x minus 67x is going to give me a negative 97x. A negative 100 minus 30 is going to give me a negative 130. And I'm going to write equal to 0 because I have nothing left over there, and that was my intention. Okay. By choice right here, it'd be super awesome if you could divide 18, negative 97, and negative 130 by something to make your numbers smaller. But I don't believe they have any common factors, so it leaves it a challenging problem. I am going to multiply 18 by that negative 130, right? You have to multiply these. So 18 times negative 130 equals... I believe a negative, is it 2,000? I gotta do it again, but I think it's 2,340. Sorry, time for Mrs. Stofflet to grab a calculator on this one. Pretty good in my brain, but I'm gonna redo it just to be sure. So 18 times negative 130. Yeah, so negative 2,340. Sorry, meaning your two numbers need to multiply together to make a negative 2340, 2,340, and they have to add to be a negative 97. So I'm going to just tell you what went on in my brain when trying to do this one. My two numbers, I'm estimating, have to be about 100. The 97 is approximately 100, about 100 apart, right? So I went and looked at this number, and I'm like, well, how many hundreds is that? So this looks to be about 2,300, right? So then I'm thinking about numbers that might be around the number 23, like, because 23 times 100 makes 2,300. What close to this would be something similar? Okay, so I tried to see, well, I know you can do it by 10, but then I tried to divide it by 20. So this number ends in 40. Also know that the number 20 goes into 100. So like if this was just 2,300, 20 would go into that. It's 2,340, and 20 also goes into 42 times. So those are just some tricks when you have really good number skills and you know your facts. It helps so much. So I divided using my calculator by 20, and I got 117, which fancy that. Negative 117 times 20 equals negative 2,340. And when I add those two numbers together, I get negative 97. So those are going to be my middle numbers. So rewriting 18x squared, negative 117x plus 20x, and rewriting my negative 130 equal to 0, right? You've got your four terms, separate it, and you have a calculator. Your factors of 18, okay, there's a lot of them, but that you know of. 1 goes into it, 2 goes into it, 3 goes into it, 6 goes into it, 9 goes into it. So take the 117 and divide it by all those numbers. What's your greatest common factor? The greatest common factor is 9, because 18 does not actually go into the 117. When you're trying the factors of 18, maybe try dividing it top down. So divide it by 18, then divide it by 9 to see what goes into it. So I can divide by 9. They both have an x, so I can divide by 9x. 9x times 2x gives me the 18x squared. 9 actually goes into 117 13 times. 9 times 13, who knew? Okay, so over here, if I'm going to be left with 2x minus 13, looks like I divided by 10. So a positive 10. These two come together, and the 2x minus 13, you write once, but you have to solve them each separately for 0. So 9x plus 10 equal to 0, 2x minus 13 equal to 0. Subtract the 10, 9x equals negative 10, divide by 9, x equals a negative 10 ninths. That's one solution. Add the 13, 2x equals 13, divide by 2, x equals 13 halves. Again, you can write that as negative 1 1/9, negative 1.1 repeating, but definitely not negative 1.1. That's a different answer. You can write this as 13 halves, or 6.5, or 6.5. Okay, so two solutions on that one. That's 47. That's a pretty good question. Thanks for asking it. And then I have 10.6, number 64. And on number 64, we have a formula that we have worked with in the past, where S is your starting height and H is your ending height, and how many seconds it would take. And I don't have my book open on this one, sorry, but I just remember that. So on this problem, it says that the starting height is 8. with an upward velocity of also 8. Okay, so those are different representations, I guess. But we're ending on the ground, so that is going to be a 0. I'm going to show you a sweet trick if you haven't been using it. But when you look at your trinomial, if you can divide everything by something, take out the greatest common factor. That's kind of what lesson 8 was like, so you didn't know it maybe when you did 2, lesson 6. But I can divide all this by 8. And look what happens if I do it on both sides to keep the equality. 0 divided by 8 is still going to be 0. So you can divide away on this side and won't change that 0. But it will bring my numbers down easier to work with over here. So negative 16 divided by 8 is a negative 2t squared. 8 divided by 8 is 1. I'm going to write that in the middle, but 1t, positive 1. And the plus 8 divided by 8 is going to be plus 1. Okay, again, smaller numbers, easier to work with. You can do that anytime you have a common factor. Okay, so negative 2 times 1 is a negative 2. Your two numbers need to multiply together to make a negative 2. They have to add together in the middle to be a positive 1. I know that 2 times 1 makes 2. So I'm going to do a 2 times a negative 1 so that I get my negative 2 when I multiply. And a 2 plus negative 1 should give me a positive 1 when I'm adding. You rewrite the first term, negative 2t squared. Your two numbers right here go in the middle, but you have to have a t on them because they add together to make this. So plus 2t minus 1t, and then you rewrite the plus 1. You separate the first two from the back two terms. I can divide this by looks like you could do a negative or a positive. I'm going to take out a negative 2t. Okay, if I multiply that just by t, I'll get that t squared. Careful on this one though, this is going to be a negative 1. Okay, looks like that. So if I divide, if I multiply this, I get this back. So on this side of things, I'm going to get t minus 1. So it looks like I'm going to take out a negative 1. These two will come together. And the t minus 1, oops, equals 0. So if I solve these each for 0, t minus 1 equals 0, add the 1. Some of you just know it, but time would be 1 second. And if I do this one, negative 2t minus 1 equals 0, and I add the 1, and then I divide by negative 2, I get a negative 1/2. This is a story problem. You are not going to get a negative amount of time, so you cannot use that in a real life scenario. You're not going to get a negative number of seconds. So time is 1 second, and that's your answer for 64. That's correct. That was an even problem, so you were not able to check that one. So 1 second, if you got 1 second, that was correct. That was number 64 on 10.6. All right, we're wrapping things up rather quickly here. I think I'm on my last two problems. So 10.7. Number 63 was with kind of a new formula. Here, I'll put it like this, easier for me to use. So this had to do with the rope again and how round, like the other one we used circumference, this is diameter, but still, if you're talking about like, this is the part of the rope you're looking at, we're asking like how far across it needs to be for the diameter of the rope. And S is the safe working load, like how much weight you can apply to it. So in number 63, they're saying 9 is the working load, and we want to know the diameter of the rope. And so since this one has to do with factoring in chapter 10, I am going to use the chapter 10 method to do this problem. So I'm going to subtract the 9 and write 4d squared minus 9 equals 0. Okay, so factoring wise, I'm noticing that there's only 2 terms. And when I factor in there's 2 terms, I ask myself, is this difference of perfect squares? 4 is a perfect square, d squared is a perfect square. 4d squared is a perfect square. 9 is a perfect square. When I factor difference of squares, one of the factors will be an addition problem, the other is subtraction, binomial if you want to call it that. Square root of 4d squared is 2d. The square root of 9 is 3. I'm going to rewrite that. 2d plus 3 and 2d minus 3 equal to 0. Okay, so if I do the 2d minus 3 equals 0, add the 3, divide by 2, the diameter can be 1.5. I am so sorry, but I am not looking at the book. I believe this was inches. I hope it wasn't feet, that'd be huge. Okay, so, or a metric, could have been, but I think it's inches, so 1.5 inches. If you solve this one for 0 and you subtract the 3 and divide by 2, you're going to get a negative 1.5, so not going to be your negative value. Okay, so 63 right there. If you want to take a screenshot of it, you could. And last problem is 67 on lesson 10.7. This was a little different in terms of the same formula we've been using. I believe it was a gymnast. Again, don't have my book open, sorry about that. I think it was a gymnast, and they're starting on the ground. And maybe it was basket, I don't know. Anyway, it's something about reaching a height. So this is the ending height. So starting on the ground, ending height, that might have been the problem, putting the problem together. Okay, so then I am going to subtract my 784 to get 0, since I'm solving. So we'll still have the negative 16t squared, still have the plus 224t and minus 784. Holy big numbers. You could certainly do your negative 16 times your negative 784. I'm going to still recommend try to see if there's a greatest common factor that you can divide every term. Can you divide this, this, and this by a same number, a common factor? I know they're all even. I know you can divide them all by 2. When I look at the back numbers, 4, 4, and 6, well, call it a 16, or I think you can divide them all by 4. Keep going. What else goes into negative 16? A cool thing, negative 16. So I'm going to divide everything by negative 16. That will make t squared minus 14t plus, because remember, a negative divided by a negative, 49. All right, so I took out a greatest common factor. Oh, sorry. I'm going to rewrite it. Your negative 16 can't go away when you divide it. It's got to stay out in the front. Now I'm questioning whether I did that with 8 on the other problem, but okay. Looks like that when you divide it. It doesn't disappear. All right, we're still working on factoring. So when I personally look at the t squared minus 14t plus 49, one, it's a trinomial. It's got 3 parts. So I know that when I factor it, it's going to have 2 factors. It looks to me like that is a perfect square. And that's a perfect square. It's fitting one of my patterns because the square root of this is 7. Square root of this is t. If I take 7t and I multiply it by 2, I get 14t. So factoring this in one of my special patterns is going to be t minus, and the square root of 49 is 7 squared. Looks like that. If you want to write it out separately, I'm saying it's t minus 7 times t minus 7. It's the same thing. So if I solve that for 0, t minus 7 equals 0. T is 7. So your answer to that is 7 seconds. This was in seconds. Time in seconds. All right, that was a long time, and that is I think the last question that I had, and that is lesson 10.7. I have gotten some questions on the worksheet. I think I posted that one also with all of my work. I am going to post the answers to the chapter 10 test page today. Want you to take a picture of that, maybe use tomorrow to ask some more questions, and I am going to post the test on Monday, basically giving you Monday, Tuesday, Wednesday. We're going to start chapter 11 on the 14th. All right.